Welcome to Spaceverse, your portal to cosmic adventures. What's this? A new segment of SpaceX Super Heavy booster has been spotted. Is this the first next-gen Starship booster? Starship 31 is getting its engines installed. How soon will it be ready for flight? SpaceX's ambitious Polaris Dawn mission is on the horizon, but is it safe following the Falcon 99's failure? Today's exploration of the most extraordinary rocket development in history begins at SpaceX Starbase launch site, or should we start calling it Build Site 2? SpaceX has been busy with construction here, making the new name quite fitting. This is where the future of space travel is being built. We expected Starship Launch 2B to be assembled quickly compared to the first because the internals of each module were already installed. SpaceX efficiency on this second Starship Tower build is impressive, though none of us anticipated just how rapidly it's progressing. Recently, we saw a major milestone as SpaceX transported the fourth tower module from the Sanchez site to the launch site. The module was soon lifted into place on top of the third module of 2B by the massive DMAG 8800-1 crane. With this module in place, Starship Launch Tower B is now over halfway to its final height of 9 modules. If the tower is supposed to reach 9 modules in height but already has 4 stacked, how is it more than halfway? The answer is that the final 2 modules are smaller, which makes stacking them easier, and the base of the tower is roughly the size of one module. This rapid progress is astounding and highlights how quickly SpaceX is able to work. The first module was only placed on the 11th, which was just 14 days ago as of this episode. SpaceX speed is unmatched in the aerospace industry, and this is a prime example of that. What's even more remarkable is that Module 4 was one of the 2 modules recently transported from Cape Canaveral. Despite this swift progress, the deadline for stacking the first 6 modules is approaching. This deadline is tied to SpaceX FAA filing for a determination of no hazard necessary for tall structures that could pose a risk to aircraft. The filing concerned the crane, and SpaceX has stated that the first 6 modules should be completed by the 27th before the crane is lowered and its height adjusted. If SpaceX stays on track, we might see the 5th module at the launch site by the time you're watching this, possibly even already stacked on top of Module 4. This new Starship launch tower isn't the only one at the site. We also have the original tower, which, despite the new tower's spotlight, still has plenty of excitement ahead. The upcoming launch will be thrilling, but what's even more anticipated is what follows. Launch number 5 will feature SpaceX's first attempt at a booster catch, where the enormous Mechazilla catch arms will try to grab the Starship booster mid-flight as it returns from space. That's right, rather than landing the booster on a concrete pad or a drone ship like Falcon 9, SpaceX plans to catch it with these giant metal arms. Currently, Mechazilla's primary role is to stack the booster and ship onto the launch pad, but why is SpaceX pursuing this approach? After all, the drone ship has been effective. The answer lies in the math. Achieving full reusability, unlike Falcon 9, which is only partly reusable, involves adding extra weight to the rocket, such as the heat shield on the ship. To compensate, SpaceX opted to forego landing legs on the booster to save weight. It might sound unconventional, but this strategy should make more sense now. To pull off this ambitious maneuver, SpaceX needs to ensure that all of Mechazilla's systems are functioning correctly. To this end, they conducted a series of tests using a specially designed test tank known as B-14.1. Following these tests, it seems that SpaceX identified some design issues, as teams were observed removing parts of the shock absorbers. This could be due to damage from the tests or from the recent static fire of Starship Booster 12. However, it's more likely that these adjustments are upgrades in preparation for the upcoming first catch attempt, which is just around the corner. The excitement is definitely building. Now that we've covered the future of Starship Stage 0 and its launch infrastructure, let's turn our attention to the build site and the development of Stages 1 and 2. We'll start in the high bay, where only one vehicle is currently stationed, the new Block 2 Starship, Ship 33. This latest iteration incorporates all the lessons learned from the first 4 flights into a significant upgrade of the rocket. As you might recall, Ship 30, the next Starship set to fly, has recently been moved out of the high bay for additional engine testing, leaving Ship 33 as the sole occupant. While we haven't seen any major new sections of the prototype emerge recently, we did get a glimpse of this, the payload bay door for the new prototype. This door covers the opening in the payload bay that will be used to deploy Starlink satellites. As discussed in our previous episode, Ship 33's enhanced payload dispenser bay was recently spotted near Mega Bay 2. This new payload bay door is likely intended for Ship 33 and will complete the payload dispenser system. Once these components are installed, we can expect to see more sections rolled into the high bay for stacking, complementing the pre-existing nose cone and payload sections. Step by step, a new Starship is taking shape. Mega Bay 1 has become quite difficult to view since SpaceX installed the large front door. However, something noteworthy recently entered this bay, a section of Booster 15, which has been there for a while. This segment contains the plumbing that delivers cryogenic propellants to the Super Heavy's 33 Raptor engines. As it was moved to the high bay, we observed the vehicle's header tank. These tanks store cryogenic liquid oxygen and provide propellant during landing burns to prevent the colder temperatures in the outer tanks from depressurizing the vehicle. This setup is different from the Starship's header tanks, which are used to manage propellant movement during the Starship's belly flop maneuver, a dramatic flip from vertical to horizontal and back during flight. The Starship's header tanks help start the engines during this maneuver. In contrast, the booster's header tanks are used because re-entry heats the booster, causing the tanks to cool rapidly. This temperature change causes the propellant to shrink, so the header tanks ensure that burning the propellant remains stable and safe. What's intriguing is that these smaller tanks are mounted externally, almost like a hat. Initially, this setup puzzled us, but we have a theory about their purpose. These tanks might be used to hold gases like helium or nitrogen for pressurization. When a rocket rapidly depletes its tanks due to powerful engines running at full thrust, something needs to be added back into the main tanks to maintain pressure. This is similar to Falcon 9, which uses helium to pressurize its tanks as the propellant depletes, ensuring they don't collapse as the fuel runs out, like how a water bottle crinkles if you remove all the water without letting in air. You definitely don't want that happening to your rocket. Starship manages this by partially burning its cryogenic propellant to generate gas, which is a simpler process. However, our theory is that the autogenous pressurization method might have contributed to the failures on Flight 3 due to the enormous size of Starship's tanks. These external tanks could help address these issues. It's also possible that this pressurization method is only used for the header tanks, while the rest of the booster relies on autogenous pressure. This is speculative, but it makes sense given the size and propellant capacity of the booster. It's also uncertain whether these tanks were used on previous flights like Flight 4. If our theory holds, this could explain why Flight 4 was notably successful. Another possibility for these tanks is that they could be serving as a temporary solution to enhance Booster 15's capabilities to support the new Block 2 Starships, potentially increasing its propellant capacity. Initially, Booster 15 was designed as a Block 1 booster intended for early test flights and missions. However, with the introduction of the more advanced Block 2 Starships, Booster 15 now needs to function as an interim version similar to what a Block 1B would be, a transitional step between the original design and the upgraded configuration. This adjustment might involve modifications to handle the increased demands of the newer Block 2 Starships, which could include additional propellant capacity or other enhancements. While this scenario seems less likely compared to other potential explanations, it's important to consider all possibilities. The inclusion of these additional tanks might be a strategic move to bridge the gap until the fully upgraded Block 2 boosters are operational. Even though this idea might not be the most probable, it cannot be entirely dismissed given the evolving nature of SpaceX's booster development and mission requirements. What do you think? Are these new tanks primarily for pressurization, signaling a shift away from autogenous pressurization, or are they a workaround to address Booster 15's lower capabilities? Or could they just be an extra feature for Booster 15? Share your thoughts in the comments below. You might be curious about what will happen to this section next. It will probably be stacked underneath Booster 15 soon, which will likely conclude the stacking of LOX tanks for this prototype. Following that, stacking of methane tanks will likely begin. We've covered a lot about the old High Bay and Mega Bay, but let's shift focus to the newest addition, Mega Bay 2. Currently, the only hardware there is Ship 31, or Sparky. This ship underwent cryogenic proof testing on July 3rd to ensure it was ready for engine installation and flight. During the test, the ship was filled with cryogenic liquid nitrogen, and hydraulic rams were used to simulate launch forces where the engines would be installed. This testing is crucial for identifying any potential issues early on. Ship 31 earned its nickname Sparky due to a problem during its last cryogenic proof test, where a pipe broke and caused an electrical fire. After the recent test, Ship 31 was moved back to the build site for inspections before the 6 Raptor engines could be installed. On the 22nd and 23rd, we saw all 6 of Sparky's engines being delivered to Mega Bay 2, with installation likely happening shortly after. 2 vacuum engines and 1 sea-level engine were installed on the 22nd, followed by the remaining vacuum and sea-level engines on the 23rd. We also noted the serial numbers of these engines, all in the 300 range, with the highest being 391. These numbers indicate the advancement level of the engines. With all 6 engines installed, Ship 31 is now preparing for its next round of testing, including smaller engine tests and a full static fire at the Massey stand. However, before Ship 31 can undergo this static fire test, the static fire stand needs to be cleared. Currently, another ship occupies that stand. So let's take a look at what's happening with Ship 30 over at Massey's. After Ship 30 was moved to Massey's last week, it was positioned over the flame trench and connected to the quick disconnect for fueling during tests. As of the recording, Ship 30 hasn't undergone a static fire yet, but it's expected to happen soon if it hasn't already. Ship 30 will be the next vehicle to fly and will be the first to feature the redesigned heat shield, which includes a new ablative layer as a backup and stronger heat tiles. SpaceX has previously encountered issues with heat tiles falling off after static fire tests, so it will be interesting to see how the new tiles perform. Ship 30 is gearing up for Flight 5, and we're all cheering for its success. While we're at Massey's test range, let's also look at the other test subject there, the new Booster Block 2 test tank. Rolled out last week around the same time as Ship 30, this tank's purpose remains somewhat unclear. It's been placed in the new Can Crusher 2.0, a device used to test Starship prototypes by applying structural stress. This tank seems to be a structural test model for future Block 2 boosters, similar to previous tests with the Can Crusher. The tank's additional rings and height raise questions. Are they necessary for the test, or is there another reason for their inclusion? We'll have to wait for further updates to understand the full scope of the testing. Now let's shift gears and explore an exciting upcoming space mission. You're probably familiar with Polaris. Here's a refresher on what's coming up. Polaris, founded by billionaire Jared Isaacman, is a series of crewed space missions. This isn't Isaacman's first venture into space. He and 3 others were the primary crew for the Inspiration 4 mission in 2021, which was the first all-civilian crewed flight to orbit. That mission spent a few days in low Earth orbit and was a significant milestone in space tourism. Next up is Polaris Dawn, the first mission in the Polaris program, and it's set to be even more groundbreaking. Unlike Inspiration 4, which orbited Earth in Crew Dragon resilience without a functional docking hatch, Polaris Dawn will involve a high Earth orbit and a major upgrade to the Crew Dragon capsule. This mission will feature a new hatch that can be opened to allow spacewalks. The primary goal of Polaris Dawn is to conduct the first all-civilian spacewalk. That's right, no NASA astronauts or Russian cosmonauts, just ordinary people like you and me making history in space. SpaceX is providing the rocket, the capsule, the suits, and everything else needed for this incredible achievement. The Polaris Dawn mission will be crewed by Jared Isaacman as commander, Scott Petty as pilot, and Tara Gillis and Anna Manan as mission specialists. Jared and Tara will perform a spacewalk, with each exiting the spacecraft sequentially. Notably, all crew members will be in an unpressurized capsule, with the Crew Dragon Resilience functioning as a massive airlock. The spacecraft will gradually depressurize while the astronauts don their SpaceX-designed EVA suits. Once prepared, the hatch will be opened, allowing Jared and Tara to conduct their tasks outside the spacecraft, while Scott and Anna support from within. After the spacewalk, the crew will re-enter and repressurize the capsule. This mission will achieve the highest orbit by humans since Apollo 17 in 1972. It could launch as soon as next month, though the original July 29th date has been postponed due to a Falcon 9 issue. The new launch date is expected to be announced once Falcon 9 is operational again. Polaris Dawn will mark the beginning of a new era in commercial crewed spaceflight and set the stage for future Polaris missions, including Polaris 3, which will feature the first crewed flight of the Starship rocket. The advancements brought by Polaris are eagerly anticipated, and we commend the entrepreneurs who invest their resources to make these missions possible. Thank you to the Polaris team for their efforts. And that's all for today's Spaceverse exploration. From the latest on Starship's incredible upgrades and SpaceX rapid progress to the thrilling Polaris Dawn mission and beyond, we've covered a lot of ground. If you enjoyed this cosmic journey, smash that like button and subscribe for more space updates.